Number 4, equations that are in quadratic form. So let's take a look at these equations. Look like they have 3 terms in quadratic form, similar to quadratic equation, but not quite. So in that case, if this is x and x squared, it should work. So the way we do that is we're going to let the middle term, let that be u. So we say let u equal to x squared, and then we will square both sides. Yeah, square both sides, and once again we have power 2 power, meaning we will multiply the powers together. 2 times 2 is 4, and that the same thing as x to the 4th here. So we have u to the 4th, u square, u, and a constant. So with this substitution, the equation becomes u square minus 10u plus 9 equal to 0. And after that, we just solve for u and then solve for x. Right. Similarly, let's look at the next one. Five x to the 2/3 plus 11 to the x to the 1/3 plus 3. So look like quadratic equation, but not quite. So let u equal to x to the 1/3. By the way, when we squared, if that is not equal to x to the 4th, we cannot write as a quadratic equation. So let u equal to one of the term and then square, and then check to see if it is equal to the other term. Sometimes I just switch these 2 terms, so sometimes u might be this term and u square might be that, if I just happen to switch these 2 terms. But on this one, let u equal to x to 1/3. And now if we square, if that equal to x to the 2/3, then yes, this will be written as a quadratic equation in terms of u. So after that, we square both sides. Square both sides. That gives us x to the 2/3. And that is the same as x to the 2/3 here. Like I said, if they are not equal, we cannot do it this way. Right. With that, the equation becomes u square, 5u square plus 11u plus 3 equal to 0. And once again, we solve for u, then we solve for x. Right. Next we have this equation, 5x to the 2/3 plus 11x to 1/3 plus 3. By the way, the x to the 2/3 and x to 1/3, those equations are the same. However, I want to make one minor adjustment. Make this 8. So the answer is going to come out nice and even. Otherwise, it may not be as nice. So still the same thing. We let u equal to x to 1/3, and then squared. Let's say if it is equal to the other term. Right. So that way we start. X to the 1/3 bu and then square both sides. Right, and that is the same as x to the 2/3 here. So with that, the equation becomes five u squared plus au plus 3 equal to 0. So we change the number from 11 to 8, so this can be factored easily. So try to find two numbers multiply together equal to the first times the last. 5 times 3, that would be 15. So first times the last give us the product of two numbers, and then they add up together, should be 8. Right. From here we see that it should be 3 and 5 because they add up to 8. Right. Now substitute, split the 8u, the middle term, into 2 using 3 and 5. Plus 3u plus 5u. Yeah, so split the au that way. And then we just factor. By grouping the first two terms and the last two terms. Our first two terms, they have u in common, and that's all we can do. So we have 5u plus 3. Right? And then 5u plus 3, there's nothing in common there. Now we have 5u plus 3 in common. Factor it out. When factor it out, we have a u left and a plus 1 here. Zero product principle. 5u plus 3 equal to 0, or u plus 1 equal to 0. Minus 3 on both sides. And then divide by 5 on both sides. Here I just subtract -1. So then minus 1. So we have u equal to -3 over 5, or u equal to -1. Right. Next, so we solve for u. The question did not ask us to solve for u, asked us to solve for x. So since u equal to x to the 1/3, by the way, we can rewrite this as a root. Right. So be this one. The top is power, the bottom is the root. So power on top, root at the bottom. So we will have x power the 1 on the top, the root at the bottom. So this pretty much just cube root of x. So u is cube root of x. So from here we say instead of u, we put cube root of x. And instead of u, we put cube root of x. And to get rid of the cube root, we will cube both sides. what happened when we cube both sides? And the answer is nothing. If we raise both sides to an even power or square both sides, then we check the answer. But this one is a cube, so don't need to check the answer. Square both sides, check the answer. Take square root on both sides, put plus or minus. Alright, so that gives us x. And now we have negative 3 over 5 cube. Now, both of them cube. So the cube go to the top and the cube go to the bottom. So that gives us negative 27 over 125. And like I said, on this one we do not need to check the answer because we do not square both sides, we cube both sides. So cube both sides, don't need to check the answer. That gives us x, and negative 1 cube, negative 1 times negative 1 times negative 1 is still negative 1. So the answer is going to be negative 1 and negative 27 over 125. Right. So that is the equation in quadratic form. We make a substitution for u, and that equation becomes quadratic equation in terms of u. But we solve for u first, and at the end we solve for x. Right. Number 5. An equation involving absolute values. Recall that on the number line 0 at the bottom, 0 at the middle, sorry. On here we have 8, the other side is negative 8. Absolute values is determined to be the distance to 0. So distance from a to 0 is a, distance from negative a to 0 also a. So if we talk about this distance, that is absolute values of a, and this is also absolute values of a, the distance to 0. Now, if a is a number that is greater than or equal to 0, absolute value equal to a number, meaning that could be negative a or a. A distance cannot be negative, therefore if a is negative, it is no solution, because distance cannot be negative. Right, let's look at first equation. Absolute values of 2x minus 1 minus 11 equal to 0. Right, so this equation similar to the radical equation, the equation that has the square root. The name of that radical equation, so try to isolate the square root. In this equation has absolute values, so we're trying to isolate the absolute values. So we're going to plus 11 both sides. So we have absolute values of 2x minus 1 equal to 11. Now 11 is greater than or equal to 0, and absolute value is equal to that, meaning we have 2x minus 1 equal to 11, or 2x minus 1 equal to negative 11. So the rule is that if absolute value equal to a positive or a number that is non-negative number, so absolute value is equal to a non-negative number, then without the absolute values it can be equal to that number or opposite to that. So that's what we have here. The rest is simple. Just solve for x. So 2x equal to 12, and divide by 2 on both sides. I will have x equal to 6 This one we don't even need to check the answer. Same thing here. But this time plus 1 on both sides. 2x equal to negative 10. Divide by 2 on both sides. We have x equal to negative 5. So we have two solutions. We can put in the solution set, negative 5 or 6. Right. Next, 5 times absolute values of 1 minus 4x minus 15 equal to 0. So once again, we isolate the absolute values of plus 15. So we have 5 1 minus 4x equal to 15. And then divide by 5 on both sides. Because we want to isolate the absolute values, meaning get the absolute values by itself. Right. Absolute values equal to a positive number. So in that case, it's equal to that number or opposite to it. So we say 1 minus 4x equal to 3, or 1 minus 4x equal to negative 3. So absolute value is equal to a number. It's going to be equal to a positive or negative of that number. But again, the right hand side here has to be positive. Or 0 minus 1 on both sides. So negative 4x equal to 2. And divide by negative 4 on both sides. So x equal to 2 negative, divide by negative 4, cancel 2 and 2 on top and bottom. We have negative 1 over 2. Divide by 2 on the top, divide by 2 at the bottom. We have 1 over 2, the negative. Just going to write on the side. Right, here we subtract 1 on both sides. And we have negative 4x equal to negative 4. And divide by negative 4 on both sides. And we have x equal to 1. So we have two solutions, 1 and negative 1/2. Right. Next, absolute values up to x plus 3 equal to 0. First, isolate the absolute values. And then notice that what we've been doing, the number on the right side, it's going to be greater than or equal to 0. When absolute value equal to that, we can do the positive and negative. When it is equal to negative, we just stop there and we say no solution. So if we have absolute value equal to negative number, that is no solutions. Because once again, absolute values is a distance, and the distance cannot be negative. Right. Next, we have an absolute value equal to 0. So can we use this? And of course, we can. So as long as the number on the right hand side is greater than or equal to 0, absolute value equal to number that is greater than or equal to 0, we can use this rule. But we'll see that x minus 2 equal to 0, or x minus 2 equal to negative 0. Of course, 0 or negative 0 is just 0. Just plus 2 on both sides. So we have x equal to 2. and then negative 0 accurate or just 0. Then with plus 2 on both sides. So once again, just x equal to 2. So we just have one solution, 2. By the way, if we know solution, if we want to write, we can say it, the solution set is an empty set. Right. So that's section 1.6. Thank you for watching. See you in another video in course algebra.